Okay, so we're talking about degrees and radians today. You guys might remember this from last year. If you just go straight to the right, this is kind of like the starting point. So this would be 0 degrees. And then if we go from there to straight up, how many degrees would that be? 90. And if we go straight across, so degrees can kind of represent the opening between two lines, but it also can kind of represent a rotation, like how far something is rotated. So if you like, that's why it's got an arrow on that. Rotate at 90, rotate 180, rotate. What's down here? Basics. Yeah, 180 plus 90 is 270, and up here is 360, full rotation. So you can call 0 and 360 coterminal angles because they stop at the same spot. And you can keep going as many times as you want. Like if you rotate 1 1/4 turn, that would be 360 plus 90 would be 450. I'm not gonna write that down, but anyways, it just keeps going. So then we get to radians. 0 degrees, this would also be 0 radians. There's no symbol for radians, just put 0. Do you guys remember what 90 degrees would be? Maybe not. Or what 180 would be, maybe? 180 is, they call it pi radians. So basically, I think where they came up with this is, you guys know in a circle, a circumference formula? What's the circumference? What is the circumference of a circle? 2 times radius times pi. So the 2 pi times the radians gets you around the circle, or radius gets you around the circle. So I think they made this up so to like help with the arc length formula, basically, because arc length is basically kind of like circumference. So anyway, they kind of took the 2 and the pi out and said that'll be radians. So a full circle is 2 pi radians. So if this is pi radians, or you could say it's like 3.14 radians, you could also say this is 6.28 radians, rounded off. If we call this pi though, what could we call this? Pi over 2, or half pi. So if this is 1/2 a pi, 1 pi, this would be 1.5 pi, or 3/2 pi, or 3 pi over 2. I think they write like that more often. Okay, if this is 1/2 a pi, well, what's this in degrees right here if I split this perfectly? 45. So if this is 1/2 a pi, what would this be? What's half of half? 1/4. I'm just trying to do like the most common ones. There's probably a table in your book somewhere just to maybe say that. Yeah, well, on page 259 has a lot of pictures of these things. So if this is like 1/4 pi, this would be 2/4 pi, this would be 3/4 pi. Or 3 pi over 4. 4/4 pi is equal to 1 pi. This would be 5/4 pi, or 5 pi over 4. 6/4 reduces to 1/2 pi. This would be 7/4, or 7 pi over 4. Okay. Another common angle, I'm not going to go through all these, is like a 30 or 60 degree angle. So 30 degrees is it's like 1/2, or 30 degrees is like 1/6 of 180, so it's 1/6 of pi. So this would be like pi over 6. And 60 degrees would be 2 pi over 6, which reduces to pi over 3. Another 30 gets you to 90, and then anyway, you can kind of count by pi over 6. I'm not going to go through all those. Okay, another trick though on rotations, if you're just measuring an angle of like a polygon, there are no negative exponents, or negative angles, but on rotations you can rotate backwards. So this rotation would be negative 90 degrees, or negative pi over 2. Okay, so all these numbers apply backwards. So if I was going backwards to this point, it would be negative 7 pi over 4 if you go backwards. And you can go backwards as many times as you want as well. That's pretty much it. You guys kind of remember this from last year a little bit? I'd forgotten we did this last year, but we did a little bit, I guess. Conversion, I think that's all we need. So 180 degrees is the same thing as pi radians. So if you want to change like radians into degrees, this is your converter. It divides out the pi's, like those cancel out, and it multiplies into degrees. Or if you want to go the other way, you just flip it upside down. This divides out the degrees and multiplies into radians. So if it was like 40 degrees, kind of, this stuff reduces to like 2 and 9, so it'd be 2 nines pi, or 2 pi over 9. So whatever you want to get rid of, you put in the denominator, and what you want to turn into, you put in the numerator. This one will be how much is that? 360 times 3, 720, 1,080, I think. Let's see your calculator. Okay, I think I said this earlier. I think this is why they made radians. Because if you do the radius times, you guys remember theta from last year? Used a lot to represent a central angle. If you do the radius times theta, where theta, if theta is in radians, that will give you the arc length. This little piece of pi right here. So that's what makes radians convenient, because it's a really quick multiply thing. So we're going to do that in a couple problems today. All right, let's jump in. Number 1, convert each degree measure to radians. Leave answers in terms of pi. So the converter for degrees to radians, there's actually kind of a quick cheat on this. I might use it. I just talked about it. It's right here. So you divide out the degrees and you multiply in the radians. This converter is legal because this is equal to 1. 1 radian is equal to 180 degrees. 1 over 1 equals 1. So when you multiply anything by 1, it doesn't change the value. That's kind of the idea. You can do this in your calculator. The way I was thinking of cheating was 315 is like 45 short of 360, so it's going to be 7 pi over 4. So if you turn back in your book to page 259, it just has that first circle just says 315 7 pi over 4. So that would probably be easier than just plugging in a calculator, just looking at that. Anyways, let's do it over here. Go back and forth. 7 pi over 4. Of course, if the number's not in the table, you would have to use the converter. So 225 is 45 past 180. So it'll be 5 pi over 4. C is 15 degrees. That one wasn't really anything I talked about. So I'll go ahead and use the converter on that one. 15 times pi over 180. So mostly it's about, you can do this on the calculator, it's about reducing the 15 and the 180. The problem with the calculator is it'll probably try to turn your pi into a, depending on what mode and what calculator you have, it might try to turn your pi into a decimal. We don't want that. 15 goes into 180, how many times? 2, 6, 12, I think. So this would be pi over 12. Negative 45. So you guys might remember that 45 degrees was pi over 4. So negative 45 is just going to be negative pi over 4. Negative 120. Well, if you flip back and look at 120, that's probably the easiest way. It's 2 pi over 3. So it's negative 2 pi over 3. 120 degrees is 2/3 of 180. So that's why. Anyway. 240. So 240 would be twice this. So 2/3 times 2 is 4/3. So it's going to be negative 4 pi over 3. Lots of ways to get the answer. I'm just kind of doing whatever I think of first. 300, I'm going to use the tables for that, is 5 pi over 3. And 360, what's 360? You guys should know this one. 2 pi. Number 5. Do you guys remember pi over 2 for number 5? What that was? 90. Half of 180, so it's 90. So since it's negative though, you're just going to put a little, whoops, you got to put negative 90 on it. 4 pi over 3. I feel like we did this a minute ago. Where was it? 3b. It's 240. Three-fourths pi, or negative 3/4 pi. Yes, I know we talked about that. Yeah, it's 3/4 of 180 is 135. So it's negative 135. Probably just look at the table for that, most of these. Pi over 6, I did mention this one is 30 degrees, so D is negative 30 degrees. Number 7. Pi, how many degrees is pi? 180. How 3/2 pi. So What's 1.5 pi? You guys remember that one? 270, so it's negative 270 on this one. C, 2/3 pi, we did this one earlier. 2/3 of 180 is 120. I'm pretty sure all of these are in those circles on the previous page, aren't they? They have not been yet. 7 pi over 6. Is that one on there? Yep, it is. 210. Just a little bit past 180. 9. Okay, this is different. You guys watching? So remember, to find the arc length, I said you just have to do the radius times the radians, the angle measured in radians, equals the arc length. So on this one though, on 9 and 10, they're giving us the radius and the arc length. So we gotta, how can we solve that for theta? Yeah, if we divide by r, that will give us the radians. So it's arc length divided by radius, or s divided by r. So on 9a, it's 6 divided by 5, which equals 1.2. And then on b, it is 6 divided by 8, which equals 3/4, which equals 0.75. Number 11. All right, so now they're giving us messy numbers. So we basically have to use the converter, use the calculator here, I guess. Probably just keep the, you guys know how to like use your arrows and go back and change the number and just leave the converter in there. So it's 95 degrees times, you want to multiply in the radians and divide out the degrees. You might just do, might just plug in 95 divided by 180 and then just put pi in your answer. That's probably an easier way to do it. But leave it in fraction form. I don't really want decimals for this. What's 95 over 180 reduced to? Oh, hold on. The directions say give answers. I lied. Give answers to the nearest hundredth of a radian. So I was wrong. So we're not going to leave pi in the answer. We're just going to put decimal answers, basically. We're supposed to round to the hundredths place. What does this come out to? What'd you get? 1.6. Yeah, 1.66. And then, so, like for B, I would just go in and change the 95 to 110. Maybe if I made you rewrite the formula over and over, you'd remember it. Oh, C, I forgot about that one. Okay, is everybody looking at C? Okay, that's, I might have mentioned this last year. I don't think I put it on a test or anything, but that's 95 degrees and 10 minutes. Guess what 10 minutes means? Well, just like a minute is a 60th of an hour, 10 minutes is a 10/60ths of a degree. So really it's like 95 and 1/6 degrees, or 10/60ths degrees. So, and then just do that times the converter. So times pi 180. This is kind of weird because it's close enough to A it actually rounds off to the same thing, even though the answer is slightly different. So D is much easier, it just gives a normal decimal. So it's 119.2 times 5/180 equals so sometimes you can write radians with the pi, and sometimes you can just turn it into a decimal. Pi is about 3.14, so 1.66 is about half pi. It's pretty close to 90 degrees. Anyways, I think I scrolled to the top. What number are we on? 11. $13. Convert each radian measure to degrees. Give answers to the nearest 10 minutes or 1/10 of a degree. Well, converting to minutes is a pain, so maybe I'll do it once. But let's stick with decimals, like tenths. So this is 1.6 radians, which is about half of 3.14, a little over half, so this should be a little bit over 90 degrees. But the converter is, you want to multiply in the degrees and divide out the radians. So it's just the converter from 11 flipped upside down. You can tell it's radians because they don't put a degree symbol. Also, the directions tells you it's radians. They probably should have come up with a symbol, like the degree symbol. Anyway, you should get 91.7, and that is a degree answer. Rounding to 1/10 of a degree. If you wanted to change it to minutes, you could just do the decimal times 60 minutes. Anyway, that would tell you how many minutes was. 0.7 of 60. I'm not going to do that. All right, that's A. B, slightly different. Doing the same thing. So that comes out as 97.4. So that kind of shows us that 0.1 radians is worth about 5.7 degrees. C, 1.21. right. 15, you guys are gonna like this one. Estimate by sight the size and radians of each angle shown below. Then measure each angle with the protractor. We'll just do the first part. To convert from degrees to radians to find its actual size. Well, about how many degrees do you guys think that is? I'm thinking it's closer to 30. But it might be right in the middle. Let's see. The book doesn't really say. Might actually need to get a protractor out. Yeah, it's pretty close to 30 degrees. So 45 is like splitting 90 directly in half. So yeah, that's about 30. So what's 30 degrees in radians? Pi over 6. They just put 0.5. I guess we'll do that. So on 16, let's give a decimal approximation, let's say. 16 looks slightly larger than 90 degrees, right? Alright, anyway, you just gotta be in the ballpark. 17, I remember doing these with you guys last year. Find two angles, one positive, one negative, that are coterminal with each given angle. Pretty sure this is on the test, if I remember right. And it's not hard. If you remember how to do it, it's not hard. So, do you guys remember what I said a coterminal angle was? It's an angle, let me go back to my visual here. It's an angle that ends at the same point. So 0 and 360 are coterminal. 90 and 90 plus 360, 450. Those are coterminal. The difference is 90 just goes a quarter of a turn, 450 goes 1 1/4 turn. But they end at the same spot. So how can we find coterminal angles? Well, what did I just do to get this 450 right here? I added 360 on, because 360 makes another full rotation. And you can also go backwards. I could subtract 360. 90 minus 360 is negative 270. And that gives me another angle. So the directions are, where did I put that? Find a coterminal angle that's one positive, one negative with the given angle. I guess we're doing degrees, and then on C we're going to do radians. So if you subtract 360, you get 140. 140 is coterminal with 500. How could I find a negative angle? Keep going. Subtract another 360. So that would be negative 220. So there's one negative and one positive coterminal angle. That's just A. Okay, B. All right, I'm going this way. It's really not that hard though. So negative 60 is my starting angle. So to get a positive, I'm going to add 360, which would be 300 degrees. And to get a negative, I'm going to subtract 360, which is negative 420. Okay, there's more than one possible answer for these. You keep adding 360 or keep subtracting 360. These are just the closest. C, pi over 4. So if we had to add 360 degrees to get a coterminal angle, what do you think we have to do for radians? Add 2 pi. This might be a little bit tricky doing in your head, but 2 pi is also 2 over 1, turns into 8 over 4. So it's 9 pi over 4. pi over 4 minus 2 pi, or minus 8 pi over 4 would be negative 7 pi over 4. Should have zoomed out. All right, D, negative 2 pi over 3. So 2 pi with the denominator of 3 would be 6 pi over 3. 6 over 3 is 2. So if I add that, I get 4 pi over 3. And if I subtract it, I get negative 8 pi over 3. Okay, I think I might let you guys do 19. Just add 360 minus 360. It's just a little bit messier because of the decimals, but yeah, nothing tricky there.